The Doppler effect is the change in frequency of a wave in relation to an observer who is relative to the wave source. We can see this effect applied in sound and light. Yes, light is also a wave. Well, sometimes. So you can picture a sound wave as a water wave, just like this. But those waves are in two dimensions. A sound wave is exactly the same, but in 3D. What do you think will happen if the source is moving? Well, sound waves move along the source, and depends on where we are, our ears detect these waves with more or less frequency. The pitch of sound depends on the wavelength. At a short wavelength, higher the pitch, and at a long wavelength, lower the pitch. Something very interesting happens when the velocity of an object exceeds the speed of sound, which is 343 meters per second. When something breaks the sound barrier, it creates a sonic boom, and the air forms a Mach cone. We can calculate the angle and the Mach velocity. We can see how the waves end up behind the source. As I said, light is also a wave, and the color of light depends on its frequency. The lower the frequency, we see red light, and the higher, we see blue light. When the light source approaches you, the frequency increases and produces something called a blue shift. If the light source moves away from you, the frequency decreases and produces a red shift. If you look at the firmament in any direction, you will see the redshift of distant galaxies. This was proof that the universe is expanding. In 1931, Lemaitre proposed that the universe expanded from an initial point, which he called primeval atom, now known as the Big Bang.